Good morning, YouTube. This is Jeremiah. I'm doing a project today for you guys so you can see what I have planned for today. I uploaded a video last night where I said I was going to experiment with my super caps to see how I could actually reduce the load of my inverter to my batteries by using the super caps. Now, a couple of you have already asked if I plan to put a 48 volt super cap in my design, and based off of my research from last night, I see now that 48 volt super cap doesn't have any more power or capacitance than having them wired up in parallel at my existing system. So with that being said, I saved the cost of having to buy $188 super caps by doing the setup that I have arranged here. And as you guys can see, I kind of drew it up, make it very simple for you. I know I'm not the most artistic person in the world, but here's how it would work. I have 1, 2, 3, 4, 5, 6, 7 batteries in this arrangement. I looked at my design last night and I saw that 3 batteries and a super cap would not properly charge the cap back. So the minimum design has to have at least 7 batteries, but the super cap would still serve the same purpose as having the positive lead that goes to the inverter. Now, as you can see, basically how this works is this: 48 volt inverter draws a heavy load. In any setting, I'd probably say, we're running 100 amps. Let's just say that's the example. Well, if it was hooked up to a battery, it's going to try to evenly draw 50 amps per battery, except for the fact that the batteries will, to provide that, actually go really, really low compared to the batteries on this end. They don't evenly distribute at a high amount of amperage coming out unless you have 8, 9, 10 batteries hooked up in parallel to kind of break that load down. Well, anyway, the super capacitor will basically take the brunt of the load, and the negatives will feed back. And I'll show you through a shunt and through my experiment how that actually works. So, thanks.